everyone, it's Alyssa and welcome to You Can Learn Math.
So today I'm talking about converting radians into degrees and degrees back into radians. Now I'm not going to bury the lead on this. If you just need the formula to do this conversion, here it is. If you have a set number of radians and you want to convert into degrees, all you do is multiply the radians by 180 over pi. And yes, that is an 8, not a slightly off 0. There we go. 180 over pi. And if you're trying to convert degrees into radians, you would multiply by pi over 180. That's it. That's it. Which is multiplying by 180 and dividing by pi. And then this one over here is multiplying by pi and dividing by 180. That's essentially what's happening. Okay, so if you need, all you need is the formula, there you go. You're set. You're all ready. However, if you'd like a little more information about why is this a thing, what are radians, and then some example problems, stick around because I'm going to talk you through all those, walk you through them. All right, so first off, what is a radian? Well, we already kind of know what degrees are usually by the time we get to radians. We know there's 360 degrees in a circle, and it's all these teeny tiny little divisions all the way around, 360 of them, that make up this circle. Radians seem very strange, frankly, when they're first introduced, because pi is in there a lot, and it's just like, oh, this is pi over 2, or this is 3 pi over 4 radians. Like, what? What is going on? Everything with radians is based off of the radius. The idea is, if you took this radius and you said this much, if I just laid this like a piece of string, imagine like a piece of string the length of the radius, and you laid it on the circumference, it would get up to about there. If I then took that and made a little angle out of it, that angle is 1 radian. That's where it comes from. Well, how many would there be in a whole circle? Well, let me zoom out. You can kind of see this from our formula for the circumference of a circle. Circumference of the circle is 2 times pi times the radius. Well, if I rounded this 2 times pi, then it would be about 6.28 times the radius. So if I took this 1 radian, this 1 radius measurement, and put it 6.28 times around the circle, I'd have the circumference. So there are 2 pi, or 6.28 radians in a circle. So whereas, as we said, 360 degrees, the whole circle is 2 pi radians. So that's where we get our baseline, and that's how we're going to get our conversion. So let's think about this. I know that 2 pi is equivalent to 360. 2 pi radians is equivalent to 360 degrees. How can I get from 2 pi to 360? What would I need to multiply by to change 2 pi into 360? Well, I'm going to split these up a little bit. This is 2 times pi, and then I'm going to multiply by something else. Well, 2 times what equals 360? 180. Pi times what equals no pi? Well, to get rid of something that's being multiplied, we would need to divide. Another way to get rid of it, oh, want that 0. Another way to get rid of it would be to multiply by 1 over pi. Same principle as if I wanted to get rid of a 2, I could multiply by 1/2, and that would equal 1, which effectively gets rid of it. So that 1 over pi gets rid of the pi, and then 2 times 180 equals 360. Woohoo, I'm there. Now I can multiply those together. When you multiply a whole number times a fraction, you put the whole number over 1, and then it just becomes 180 times 1 on the top, and 1 times pi on the bottom. So I'm saying I have my radians, I multiply by 180 over pi, I get 360. And that's where that formula came from. And you can go through the same process to do the other way. 360 to get to 2 pi, you multiply by pi over 180. Same process. Now let's put these into practice. Let's try a couple of them. And there's just a couple things. I mean, this is a more simple formula compared to some of the other formulas that get thrown at you in algebra and geometry and trig. But there's a couple of little things I'd like to make you aware of. So let's convert from degrees into radians and radians into degrees, one of each. So let's say I had 90 degrees and I wanted to know how many radians that would be. Well, my formula says to take that 90 degrees and to multiply it by pi over 180. So same sort of thing as before when we have a whole number and we want to multiply it by a fraction. We're going to put it over 1. So then 90 times pi on the top gives me 90 pi, and 1 times 180 on the bottom gives me 180. Now the crucial thing with these is to not leave them like this if you can simplify them. If you can, always, always, always simplify them. So in this case, we want to see if there's a number that goes into both 90 and 180. I can't do anything about the pi because there's no pi on the bottom, so there's nothing to cancel out. The pi stands alone. So it's just the 90 and the 180. Does any number go into both of those? Well, a lot of them do actually. 3 goes into that, 15 goes into that, 45 goes into that, but I want the biggest number, and that's 90. 90 goes into both of them. 90 goes into 90 one time, and 90 goes into 180 2 times. So I'm left with 1 times pi, or pi on the top, and just 2 on the bottom. And there's my answer, pi over 2 radians. Now in other algebra problems, if you got an answer like pi over 2, there would be cases where your teacher would prefer you to write 1/2 pi as your answer. However, when we're talking about radians, leaving the pi in the numerator is the acceptable standard way. It's pi over 2. So just leave it like that. Now let's go the other way. Let's go radians into degrees. Let's say I had 3 pi over 4 radians, and I'm wanting to convert that into degrees. So for this one, I multiply by 180 over pi, the flipped way. I'm just gonna, we know this is radians, I'm gonna get rid of that just for the sake of keeping it nice and clean. So 3 pi over 4 times 180 over pi. Now I can, just like with a regular fraction, the fact that a pi in there does not change this, pi is in there does not change this, I can cancel things out before I multiply. It makes things easier. I like to do it. You don't have to. You can go ahead and multiply these as is and then simplify afterwards. Frankly, it's just easier to do it beforehand. So we're looking for things on top and bottom that have greatest common factors that we can cancel out. Well, first off, pi. There's a pi on top and there's a pi on the bottom. Boom, boom, be gone, pi. Then I see 4, I see 180. Those are both even numbers. Also, would 4 go into 180? So no, at least 2 does. So I check, no, yes, 4 goes into 180. Hey, I can cancel out the 4 on the bottom. And how many times does 4 go into 180? It goes into 180 45 times. So now and when I canceled out these pi's, by the way, it just leaves 1 in both places. It doesn't magically disappear, leaving a 0 or something. It's the 1 is what's left behind. So on top, I have 3 times 1 times 45, or 135. And on the bottom, I have 1 times 1, or 1. Get rid of that line. So 135 over 1 is just 135 degrees. So 3 pi over 4 radians is equal to 135 degrees. So again, simplification is the key. That is the big thing that may trip you up in these. But other than that, it's going to be a pretty straightforward formula that you need to use here.
I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.